Okay, so first of all, thank you very much for having me here tonight. It's a great pleasure and an honor to speak here at this occasion, at this very interesting and exciting panel. So, my name is Kристiνα Μπουντε. I'm representing BASF today, which is actually a chemical company. And I would like to speak a little bit about this concept of chemical recycling and highlight one project which we are doing on this endeavor of establishing chemical recycling. Now, I said before, BASF is actually a chemical company, so a few numbers. We have a globally operating company, basically delivering into all industries and all kinds of chemicals, ranging from base chemicals to more advanced materials, coatings, agricultural products, you name it, and also plastics. And when we look at the plastics portfolio of BASF, it is actually a portfolio that is which are applications that are not so commonly known or not so commonly associated with when people hear the word plastics, because usually you think of those items you see a lot in your everyday life. You think of the plastic foil, the plastic bag, the plastic bottle, and that is an important part of it, but it's not all. And I was therefore also very delighted to hear in the presentation before about all the other sectors, and especially, for example, the construction sector, be it floors, be it insulation materials, which is one of the big sectors for BASF. Also, the contributions that plastic have in transportation as a lightweight material, so transportation is a second big sector for us. And then the third one is industrial, which is, for example, industrial machinery, industrial products. And lastly, then also consumer, and there you also have a lot of other items where you actually end up have plastics as a base material, like for example in your running shoes or in much of your sports gear, you actually were using plastic products. So this is a broad variety of materials, and that also leaves you with a lot of different approaches on how to implement circularity for all of these kinds of materials. Now, as BASF, we believe that creating this circularity is really something that has to come with the value chain. It's not something that we as producers can do as our own. It's something that really comes with the converters, with the recyclers, with the waste industry. And we see quite a few initiatives going on along the value chain, and I think this is a really important driver for change. So listing just a few here, which we are active in, is the Alliance to End Plastic Waste, which has been already introduced. It's an industry-led initiative to reduce plastics in the environment. We are active in two initiatives by the Almec Arce Foundation and also in the Circular Plastics Alliance, which Alexandra has introduced, with the objective of having 10 million tons of recycled plastics brought into the European market by 2025. So it was already mentioned before, chemical recycling is seen as an alternative, so or as an add-on that has to be established and that can play an important role. And when you think about the different options of what do we do with plastic waste, well, we have this one option which we all don't want, which is landfilling and, of course, littering. These are the options that we definitely all agree we want to end. You do have the option of actually recovering part of the energy that is contained in the plastic, so that's either using it as waste to fuel or incinerating with energy recovery. So there, at least, the plastic serves a useful purpose and substitutes, for example, the fossil fuels, which would be used in a power generation instead if it wasn't the plastics that is incinerated. So there is a value, but it's not a circular economy. And when we look for the circular economy, we really think that there is two elements. It's mechanical recycling, which is already largely implemented and which has a lot of very good applications so far. And then also there is the chemical recycling, where I think that is also an important add-on, which can actually benefit the mechanical recycling. So if we take those two options together, we will come up with a much higher total recycling rate, and I think this should be really our objective. So just what is actually mechanical and chemical recycling? So mechanical is the typical one that you know, where you take the plastic bottle, you melt it down, and you make some granulates, which you then melt again into a new product. Or you have the chemical processes, and actually people often think when they hear chemical recycling, oh, that means that you use a lot of nasty chemicals. No, it does not. It means that you use chemical processes to turn the plastic back into feedstock, which you then use in your production. And I will explain how that works in a second. So when you look at the pilot project, BASF is currently running a pilot project to establish chemical recycling, to establish one form of chemical recycling based on the process called pyrolysis. And this one really starts here. It really starts with the waste, and it starts with the proper collection and sorting. And we've heard before that actually sometimes even the issue starts here. So this is the first thing that has to be in place if you really want to establish a circular economy. Now, the second element is the so-called pyrolysis. And pyrolysis is a form of a chemical reaction of your plastic. What you basically do is you take it, you heat it under exclusion of oxygen, and you basically break it down into oily components. And when you think of plastics at the moment, these are made from oil and gas fractions. And by pyrolysis, by the thermochemical process of pyrolysis, you get back to those fractions. And those are the ones which you can then use again in production of chemicals and production of plastics. We are then producing plastics with recycled content. And maybe here one word, this is actually an allocated recycled content simply due to the fact that the overall turnover in an integrated chemical production is much, much larger than the amount of feedstock you can at the moment generate from the pyrolysis process. So you have a huge dilution factor. So similar as with green electricity, you say, okay, we have a certified allocation process where you can allocate what you have put into the system. And that was actually certified by a third party to make sure that there is no double booking, that losses are taken into consideration, that it's all going a smooth route. And then you actually have your plastics with the allocated recycled content. And then in an ideal circular economy, these are actually disposed of properly by the consumers at the end of life. And then we end up in a collection and sorting, and we are finally able to really close the circle for a circular economy of plastics. Now, where is the added value? Why do we need this? And I think there is a few elements which are really critical for chemical recycling. The first one is you can make waste streams, you can make plastic waste streams available for recycling which are not suitable for mechanical recycling. Be it, for example, because they have been recycled mechanically a few times, so the properties have degenerated. So at the moment, this would mean, okay, they have to go to incineration. With chemical recycling, it can actually be an option to turn it back into feedstock. Or otherwise, if you have materials which for some reason have come into contact with nasty stuff, it has been under the hood plastic component in a car, well, you may not want to recycle that. So this can become available for recycling. One important element is that by going back to the oily components and by going back to the feedstock, you have a possibility to remove substances which are undesired and which could have negative implications in the second circle. So thinking, for example, in the future, when you look at, for example, plastic products which come from industries where the waste is, or where the materials have a long lifetime, and where the composition of the material is that was perfectly legal, compliant, state-of-the-art 20 years ago, but now it's coming back, and the materials in there, be it flame retardant, plasticizers, etc., may not be permitted anymore. What do you do with those? Well, chemical recycling, and especially the thermochemical processes, can be one way of dealing with such waste streams. And then I mentioned before, you have the possibility to turn plastic waste back into feedstock for chemical production. And very important, you really have a high quality performing plastic. So Alexandro mentioned before the current limitations that you sometimes have when you want to use recycled plastic. Sometimes it's perfect, but there may be applications where you find, okay, I can't get the color quite right, or I cannot get quite the mechanical properties. By having gone through the whole process of the chemical production, you actually end up with a plastic that is really as new. It is as good and has the same properties as the materials we are producing now. And so this is, for example, also visible from the pilot products we have done so far. So here I've summarized what the status of the project is. So at the moment we are still at the, I would say, transition between demonstrating proof of concept and moving to larger implementation. So we have fed the first charges of pyrolysis oil into our production. We have allocated these to new products. So for example, we have used a drawer of a fridge. So in part or in the fridge component, transparent, high performance, food contact approved, that has been produced. Another one was a cheese packaging for mozzarella cheese. So these are applications where we have really demonstrated that you really get back to this super high quality. And this has been done with our partners, with converters, And the certification system for the allocation of the recycled content has been developed by an external certification provider called EcoCycle. What we have really gained so far over the project is a lot of further insight, deeper cooperation with the whole value chain. I mentioned before, this is critical. And we have really worked a lot with the waste industry, with the customers, with the converters, etc. And this has really been an important learning experience also to really establish the networks and the partnerships along the value chains. And quite recently, we also had an investment where we have invested into a Norwegian technology provider of the pyrolysis process. They're called QuantaFuel. And we have now invested a 20 million share for the first pilot plant, which is actually about to take up production as we speak, or very soon after we speak. And that plant will have, once it has reached full capacity, a 16,000 ton per annum capacity. So I would say we are still in the process, and what we still need to do is to really finally evaluate the technology, also to develop those parts which are not running as stably as we would want them to really get this scale-up done, from proof of concept to really high scale-up to relevant volumes. And in the end, what we also need is the understanding and the acceptance in the market for chemical recycling and for the products you can get from those. And in the end, it is really a combination of, on the one hand, having a technology development. I mentioned you have to get this technology to scale, which means you have to do all the scaling up dirty work in the technology and in the plant. But at the same time, I think we also need the right regulatory framework. Because if the technology is new, then people are like, okay, is it accepted? Is it something the European Union wants? Is it something that my local country wants? And we see some really promising moves. So, for example, the Circular Plastics Alliance of the European Commission has been crystal clear that chemical recycling, yes, it has a role to play. But then there are also the downsides, where we see that national policies say, oh yeah, maybe it's not the greatest kind of recycling, I'm not so sure about this. And of course, that also sends a signal. So I think in the end, if you have the supportive regulatory framework, then also the technology development, this technology can really bring recycling to a level which we have not reached before. And with that, I would like to conclude my presentation. Thanks a lot for listening, and it was an honor to be here.